Okay guys, let's move on. Now, the same as the previous one, we finished all the steps. We rejected the null hypothesis, so we established that there's a difference, we established that there's an effect. But now the last thing is we want to tell how big is the effect. And that one is going back to the measures of effect size. Again, you do this only if you reject the null hypothesis. Only if you reject the null hypothesis. If you didn't, then there's no point of doing this because you didn't find an effect. If you found an effect, tell me how big is the effect. Same as the previous one, we gotta do Cohen's d. And Cohen's d at this point is different compared to the independent samples t-test. We were looking for a differential. That's our main interest. Find the differential. What is the differential of the scores? Once we establish a differential, say if we have 10 participants and the differential was 150, then you're gonna find a mean, an average of the differential. If I had 150, which was the differential, and I had 10 participants, I'm gonna divide 150 by 10. That's gonna give me my mean of the differential. And you're gonna divide that by the standard deviation of the differential. If you remember, I told you to put it on the side in the previous video. Put on the side once you have the variance, the estimated variance of the differential. On the side, put in the standard deviation because you're gonna need it. That standard deviation goes here and is the square root of the variance of the differential. Once you get this number, same rules. If you get a number that is lower than 0.2, small, 0.2 to 0.8, medium, and over 0.8 is a large effect size, this is what you want and you want to get published. Simple, up to the point. Now, in the proportion of variance, the obtained value is going to be squared divided by the obtained value plus the degrees of freedom, which is pretty much almost the same as the previous one. The difference here, of course, compared to the independent samples t-test, the degrees of freedom in the independent samples t-test is based off two groups. But here, because you're testing the same group of people twice, the degrees of freedom is coming from one group. So you're going to see it here. Typically, the proportion of variance here tends to be bigger than the independent samples t-test. Just because you maximize the outcome of the results when you have the same group of people being tested more than once. Most often, if you're going to find an effect, you have a better effect when you test the same group of people twice. But in practice, that's more difficult to do because getting a participant for one study is hard, and getting the participant to come back again makes it a little bit more hard yet. Omega squared is a more conservative measure and is preferred by some journals. It really depends on where you're trying to report. And then yes, at the end, report it. Again, establish what was the interest in the study. Then highlight your descriptive statistics. Go on and move on with your inferential statistics. Tell us the alpha level. Tell us the obtained value. Make sure that you mention if you find an effect size, how big was your effect, and what is the proportion of variance in the effect. And lastly, tell us that you reject or fail to reject the null hypothesis and what do you concluded. And that finishes off the related samples t-test. Well done.